The history of human progress centers around the wheel. The wagon wheel removed the load from man's back and made him better than a beast of burden. The wheel brings water to crops, turns wheat into flour, converts nature's energy into electricity, and transports people and goods to the ends of the earth. Circular motion is present in machines that have dominated our way of life from ancient times to modern times. To relate circular motion to mathematics, look at this circle of radius 1, called a unit circle. The length of its boundary is 2 pi. When an object moves along the circumference, the distance it travels can be recorded on a horizontal t-axis. The number t is called the radian measure of this angle. The word radian is short for radial angle. When you wrap one radius of a circle along its circumference, the angle formed is 1 radian. If you want to fill the entire circumference, you need a little more than 6 radians. 2 pi radians to be exact. This angle, halfway around the circle, is called a straight angle and contains pi radians. This one, 1/4 of the way around, is called a right angle and contains pi over 2 radians. And half of that is pi over 4 radians. When a bright spot moves around a circle, what you actually see depends on your point of view. You see a true circle only if you look at it from the right direction. You might see motion along an oval curve called an ellipse. Or you might perceive the motion as being straight up and down, as though the spot was casting a shadow. The height of the shadow above or below the shadow of the axle can be measured on a vertical y-axis. When you plot y against the angle t, you get a graph called a sine curve. The number y is called the sine of t, and written this way: y equals sine t. The word sine is the English form of the Latin word sinus, which means bend or curve. In this program, we will become better acquainted with some sinuous curves.